Oh, hi. Hello again. Welcome to another segment of Weld of the Week. Again, I'm your host, Mr. Postma. This week, we're going to be looking into stick welding. Not that kind of stick. Much better. Grab your helmets, grab your torches, let's get sparking.
Weld of the week, it's weld of the week, yeah, weld of the week, it's weld of the week, now weld of the week, it's weld of the week, yeah, weld of the week, it's weld of the week, yeah, laying beams, stacking dimes, perfect passes every time. Weld of the week!
Welcome back to another episode of Weld of the Week. This week we're going to be looking at stick welding, but first we need to do some review. Last week we talked about PPE or personal protective equipment. Welding specific PPE includes welding helmet, minimum shade 10, our welding jacket, and our welding gauntlets. This week we're going to expand a little bit more on these puppies.
Well, Mr. Postman, if I'm wearing my welding helmet, why do I need to wear my safety glasses?
Great question. Let me tell you. Not unlike the sun, welding produces extremely strong ultraviolet or UV rays, and we've all been told before, don't look directly at the sun. Well, it's the same with welding. You shouldn't look directly at the weld. However, sometimes in the shop, you can't avoid it. But if you're wearing these guys, our CSA approved safety glasses, they're 99.9% UV protected, which means if you're walking around the shop without your welding mask on, you walk by the welding booth, and someone forgets to say, watch your eyes, you're gonna be okay. If you're not wearing these safety glasses and you look directly at the welding arc, you could suffer what's called arc eye, which is this gritty, sandy feeling. It's kind of like a sunburn, but directly on your cornea. Not a great time. So make sure you're always wearing your safety glasses. This week we're gonna be looking at stick welding. Proper term for stick welding is SMAW, shielded metal arc welding. It is one of the older forms of welding in history. Now, setting the welder for this is a little bit easier than our MIG machine. We only have one setting to worry about, and that is our amperage. You can see here we have a huge amperage range. There's a bunch of rings with a bunch of numbers. The best way to set this is to look up the type of rod that we're going to be using, and it will give you an amperage range. The easiest way to do it is just on Google. Today we're going to be looking at using a 6011 1/8 rod, and I'll explain a little bit more about that later. Now, for a 6011 1/8 rod, the amperage range recommended is between 90 and 140. Now, in the flat position, 140 is quite high, so I would stick to closer to the other end of that. So maybe between 100 and 110. And the way we can read that is by looking at these different circles in here. Now, if you take a look at the bottom, we have on the left-hand side, which is where our ground and our torch is actually hooked up to, it says DC. On this side, where we don't have it hooked up, it says AC. And if you take a look at the bottom here, it actually shows you which range that we're working in. So it says DC on the bottom in the black and AC in the white on top. So since we're hooked up here on the DC side, that is where we're going to be setting our amperage range. Now, if you take a look on the left-hand side here, it shows our range selector. So we have the low and the high. Right now we're set to low. We come back to our chart here in the DC. The inner black circle is our low, and the outer black circle is our high. So you can see here, if we had this set to high, the very lowest we could go is our 90, which is the minimum for our 6011 1/8 amperage range. Take a look here, we have our little finger pointing to the area of our amperage setting, and right now it's set to about 90. Like I said, you probably want it a little bit hotter than that. Don't want it on the very low range, but you certainly don't want it in that upper 140 range. So we're gonna set it about there. That's about between 100 and 110. And then to turn it on is just this light switch on the right-hand side. For those of us who have been paying attention, you might be thinking, okay, so we set our machine, now it's time to set our shielding gas. Awesome observation, but not quite. In stick welding, SMAW, we don't use shielding gas. We use what's called an electrode. There's a few components to the electrode that we need to be aware of. We have this metal rod that runs the entire length of our electrode. This serves a couple purposes. It establishes that arc between the welder and our material that we're welding, and it acts as our filler material, so kind of like the wire in MIG welding. This is our weld puddle. You'll also notice we have this kind of coating on the outside of our metal material. Now that is a flux, and the flux's job is to protect the weld, as the shielding gas does. So as the rod is burning, as we are welding, this flux is burning along with it. And what it's doing is creating a little gaseous bubble around our weld and protecting it from contaminants from both the material and atmospherically. So we need both of these in order to create a successful weld while stick welding. Now you'll also notice we have some numbers on our sticks. This one is 7018. This is probably the most common welding rod you'd ever see in a shop. However, it can be quite difficult and temperamental to work with. So first, we're gonna start with 6011. And they will all have that writing at the top. If you are unsure, just ask and I'll direct you. Next up is our stinger. This is the tool that holds our electrode. To open it, you just want to swivel left, and then to close it, swivel right. We'll take our electrode, and the bare portion of it goes inside, hold on to the head, and then you're just going to tighten that up, like so. Now that isn't moving anywhere. Now you can bend and reposition your stick depending on the style of weld or the position of the weld that you're going to be doing. So funny story, it turns out that the welder was way too loud and the audio didn't quite sync up with the video. Guess it was arcing up a bit, haha. Don't worry, I found a grounded solution and now we're good to go. We've got our machine set and our electrode chosen, so it's now time to start sparking. Quick note, the machine was running pretty hot, so I ended up dialing that amperage down to 90 anyways. You may even want to go a bit lower depending on your technique. Now a little bit more of the stick welding versus MIG welding showdown. A lot of beginners start with MIG welding as it's kind of like the cruise control of welding. But with stick welding, it's inherently a bit more challenging. MIG is great for clean metal in a controlled setting, but stick welding is your best friend for outdoor work, rusty metal, and thicker materials. It's like the all-terrain vehicle of welding. It doesn't care what kind of conditions you throw at it. MIG is also great for going in all sorts of directions and not giving you too much of a fuss. But remember with stick, we have that flux coating, which then creates a black byproduct for protecting the cooling weld, which is called slag. To help you remember, if there's slag, you drag. This means when using flux-coated electrodes, you should always pull the electrode rather than push it. Why? Because dragging helps keep the molten weld pool protected by the slag, leading to a stronger, cleaner weld. If you try to push stick weld, you're basically asking for trouble. Think of it like pushing a shopping cart with a busted wheel. It goes all wobbly, fights you the whole way, and make you question all your life choices. Now let's start talking about your arc. If you're struggling to get going, don't worry, it happens to the best of us. It's kind of like striking a match. Too slow and it won't light, too fast and it won't catch. You want a quick, confident motion, just like signing your name on $1 million welding contract. Hey, dream big. One final pro tip, watch that arc length. Too short and your electrode will end up sticking. If it's too long, then your arc will wander like a lost puppy. Keep it about 1/8 of an inch from the material for your best results. If the electrode does stick, don't panic. Loosen it from the stinger and pull the stinger off the electrode. Then you can let it cool down and remove by hand. Then you can turn the amperage down slightly, practice your striking motion, and do it on scrap metal first. So as you may have noticed, stick welding, especially with 6011, is a lot filthier than MIG welding. So we need to clean this up. Like I said, we have a slag byproduct that's from the flux for protecting our weld while it cools down. And you can use a chipping hammer, a wire brush to clean all this stuff up. And my favorite tool for this is our wire wheel from our angle grinder. Okay, now when it comes to angle grinders, remember, never use one that doesn't have this guard here or this handle. Okay, we need both of those in order to use this. And use this very carefully. If you hit a corner or an edge, this can bounce back up at you. So make sure that you're using it properly and letting it do the work and not forcing it to do the work. Also, do not forget to wear your face shield and your hearing protection. And there you have it. Now you have 4 nice 6011 stick welds in the 2F position. Well, there you have it. Another successful weld of the week. I hope you could use these tools, tips, and tricks to add to your welding tool belt to help you become the next best welder. Hope it was weld worth it. We'll catch you next week on Weld of the Week. Keep on sparking.
Weld of the week, so what do you think? Weld of the week, it's weld of the week, yeah, weld of the week, it's weld of the week now, weld of the week, it's weld of the week, yeah, weld of the week, it's weld of the week, yeah, laying beads, stacking dimes, perfect passes every time. Weld of the week!